Okay, hello AutoCAD class. I've made this quick video just to show you about Sketch 3. I hope this helps. So what I did is drew it off to the side here, and then I'm going to draw it again in this space so that you can actually see the strategy, and also how to use a couple different tools that I will admit I wasn't as familiar with until this year when I started playing around with them more. The first one is the polar coordinate drawing with the relative coordinate system, and doing that both in a linear way but also in a polar coordinate way. So here's the first step. So if I'm going to start from this corner going up, and it's in the distance of that is 60, and so I'm going to start, I'm going to use a P line. So I type in PL. I will draw it at my 0, 0, 0, 0, enter, and keeping my O snaps on because I know the exact height, so I'm going to type in 60. Then this is where I will take the O snaps off by pressing F8, allowing that to rotate, and that's because this kind of helps me out. You can see the dynamic information on the line, which is helpful in knowing not only what approximately the length would look like, so there's about 65, but also notice the angle in gray there. It says 27 degrees. Well, what we want is a 67-degree angle. So first thing, if I'm going to use this relative coordinate system, I have to first type in the @ symbol, okay, and then I can put in the exact length of the line, which is 65, and then I'm going to hit the less than arrow, and you notice it puts me over here and allows me, now my line's exactly the length, it's not going to change the length unless I hit escape. And now I can play around with what that angle would be. So if we're using polar coordinate system, remember, check how the number changes. There is 0 degree on a polar coordinate system, and then if I rotate counterclockwise, I get to 90 degrees. And then if I go continue counterclockwise, I'll find 180 degrees. I then find 270 degrees, and then all the way back around until I hit 360, and then back to 0, 360 again right there, okay? So what does that mean for us? Well, if I'm going to rotate from this endpoint here out, and I'm going to have to know that if this is 370, I want a line that is located between, 270 and 360, right? So I'm going to add 67 to 270. So when I add 67 to 270 on my calculator, I get 337. So this is where I'll type 337 and hit enter. And I have gotten my angle, which, yes, is 67 degrees, but in terms of rotating like the clock, it is at 337 degrees if I were to rotate from that center point. Now we have a new center point. Again, I'm going to start the same way. I'm going to put the @ symbol in so that I can actually now type in my new location from that actual point. And what you'll notice again, now the center of the clock, if you will, has rotated to here. And when I go over and see what the angle is, the angle here is 157. Okay, so that's 157. So let's look at that again. We have 90 is basically straight up and down. Let's start with 0. So you've got, there we go, 0 degrees, 90, 180, okay, and then all the way down to 270, and then we'll go all the way back up to 360. So imagine that's the center of the clock and it's rotating in the polar coordinate system. Well, the information that's given is that this arm, if you will, is at 99 degrees, which is roughly in this area over here. So I have the @ symbol in, and we know the length of the line is 45, so I type 45, and I'll hit enter. And then I'm going to put the less than symbol. Oop, let me do that again. I'll escape. One more time. Okay, from this point, I'll put the @ 45 and less than. Okay. So again, here we are at the end of that line. There's the 90. Our angle is 99 degrees from this line. So if I add, or subtract rather, 150 subtract 99, I will be about somewhere in here, 40, 50 something. So I take the calculator out again. Remember over here, I'm looking at the information after I've moved my center point over here, 157. Okay. So on the calculator, I put 157. I'm going to subtract 99 to figure out where that would put me. It says that it will put me at, oops, one more time, 157 subtract 99 at 58. So I'll type in 58, and there is my line. Okay, now it makes a lot of sense for me to go ahead and press the F8 button so that I have my ortho on, because I know the exact length is 30. I'm just going to use that to help me draw it. The next line, okay, again, I'll take my F8 button off and I can now rotate freely. You see we're given the length of this line to be, right here, 36, okay, and an angle is 39 degrees from here, 139 degrees. So if this is now, according to this line, 90 degrees, and this is 0, and this is 90, oops, rotate, you're going to find your 180. Okay, so we got 90, 190, there it is, 180, 270, 380. Okay, so now from 270, I wouldn't want to rotate this way because I'd have to add some strange number. So what I would probably do instead is I would say take the angle 139 and I would subtract it from 360. Well, first off, I would subtract 90. Let's see, I'll subtract 90, right? So there's 360. Okay. So again, notice if you look here, if I go from this point and I rotate up this way, I have to come out 90 degrees plus whatever's left over. Okay, so I subtract out that 90 degrees, that gets me back to 360, and then whatever's left over is what I would rotate. So I'm going to take 139 on my calculator. I'm going to subtract 90 degrees out of that, and I'm left with 49. So I'm going to put in 40. I'm going to type in the length first with the at symbol, at 36 less than 49. And there's my line. Okay. Then notice it's a parallel vertical line, so I'll put my F8 back on, and I'm going to type in 80, enter. Okay, now this last line, this is where I hit enter again and get out of the drawing command, because notice they don't actually give me a length for that. So I'm going to come back to this end and just simply draw the 80 and the 15 and then connect the 2 points. So I'm going to go P line. I'm going to type 80 and then 15 and then simply connect the 2 dots and I will have that last segment in. Okay, hope that helps. That is called the relative coordinate system using the at symbol.